All right, everyone. Thank you very much for being here. We hope you've been enjoying the show as much as we have. It will be our pleasure, myself, Vincent, and my colleague François, to keep the show going with you today, talking a little bit about automating QA in video games. We might be cross-industry here in the room, so just to be sure we all know what we're talking about. Video games are highly technical works of art. That means there's a lot of stuff that can go right, but also go wrong. So the activity of keeping all this piece of software in check along the process is what we call quality assurance or QA. To give you a little bit of context, the AAA game, the modern AAA game, its budget is pretty big nowadays. It's growing bigger year by year. And everything we do about the QA is quite a sizable portion of this pie. We estimate that the work of the quality assurance experts amounts to around 15% of the budget of production. But if you factor in the development work that follows from the technical problems that are surfaced in the work, that can sum up to about a quarter of the production budget. Of course, this figure varies widely depending on the project and the exact parameters, but nonetheless, it's a pretty sizable chunk of money, so we definitely want to be smart about the way we spend it. Ideally, whenever there's a change made to the game, we'd love to be able to test with 100% coverage in a world with unlimited resources. Unfortunately, you may be aware that we do not live in such a world, so we have to prioritize, we have to figure out what tests are most important to play at what moment, and we've been doing that very well for a while. But our games, they keep getting bigger, they keep having more opportunities, of course, for unique player experiences, but these translate into more opportunities for technical failure also. So the compromise we make with the resource we have is getting more dire as the scopes keep getting larger. So this has brought, in the last few years, lots of discussion about being able to automate some of the game testing that we do. So the idea behind that is using the same amount of resources that we currently use to manually perform these tests. Is it possible to instead share some of that workload with compute resources so that overall, with the two bandwidths combined, we can ensure more coverage? However, even though we've been having this discussion for a while, we fail to see any standard approach to automating tests establish itself as a standard practice in the industry. And we believe this is the case because most of the attempts at seriously automating big parts of QA have been isolated within single productions and therefore have incurred lots of initial development costs, which prevented us from catching the early bugs, which are those that save us the most money, and so on. We believe at Gearbox we've found a way to break out of this vicious circle with an approach that we have packaged in an Unreal plugin that we're going to dive into with you guys today. So we're going to present to you a plugin called Polaris, which is a framework that lets you build and maintain automated tests without the need for coding. I want to take a moment right now to acknowledge the team that with us is building this tool. So of course there's François and myself, but also Alexandre, Mazad, and Charles, which are part of the team. So the way we're going to break it down today, François is going to let you know everything about what exactly the framework looks like, what the principles are, and what the editing experiences looks like when you're building your automated tests and working with them. We're going to look at some examples, what classes of tests this allows us to put onto computing resources and automate them. Of course, it's not enough to have a nice and cool tool. We have to integrate it in our workflow in the everyday life. So we're going to look at what the QA cycle along with the dev looks like and how it's impacted by having a tool such as Polaris. And we'll conclude by giving you a glimpse of the future features we're working on to bring to this tool to enhance yet more the scope of what we can do. And of course, keep in mind any comment or question that you may have along the presentation, as we'll have time to answer them at the end. So without further ado, I'll pass it on to François to introduce you to the tests in Polaris.
Thank you, Vincent. Hi, everyone. So before going through with a demonstration of the plugin, I would like to take some moment with you to explore some of the few key concepts we need to think about when we're developing that type of tool. Let's start with the test. What do we mean by the test in a video game, in a gameplay scenario? Typically, we have an initial game state. This means that we have some information about the player location, the number of enemies in the world, their health, and we want to perform some kind of action. We do some function. Let's say we move around, we interact with the stuff in the world, and from those actions, we get a new game state. And this is on this new game state that we can perform the validation test to make sure that the function we did perform the way we expect them to do. And that's the test we're talking about today. For Polaris, I'm going to focus mainly on what's in the middle, the function, so I can explain to you how we interact with the game to create exactly the test that we want to evaluate. So let's start with a simple example. We have a beautiful game here where the goal is to reach the orange box. So right away, we need to deal with navigation. One way to do it could be to record the raw input data from the controller. Let's say I'm holding the left joystick in the correct direction for a few moments until I reach the box. But as you can imagine, this kind of framework will be very tedious to maintain in the long run. As soon as there's any change, in the world, you have to update those plans. A simpler approach is to use targets or waypoints in the world, which are simply a coordinate, like the location in the world. This way, the agent, the bot, can simply move to the target and get the box. And here, this idea, this node, is the building block of Polaris. Everything you're going to see in the next slides is based on this idea of a node where we can do some stuff. So if you take those nodes and you combine them together, you get a plan. And with this plan, you can do some testing. You can evaluate the game state at a specific point, at the end of the plan or at the end of each node. And of course, those plans are associated to a specific level, and they're categorized depending on the use case of the thing that you want to evaluate. So in that example, if we want to avoid the wall in the middle, we just combine two waypoints together, and we got a valid test. But what happens if the box gets a brain of its own and start moving around the world? With the previous approach, we don't want to add a lot of nodes along the path of the box trying to catch it. Like a better idea is to attach the node directly on the object that we want to track. This way, even if the box is moving around, the plan will update itself. So we can attach it by using an actor reference in Unreal. Another concept here is sometimes we want to interact with object in the world more with specific action. So here we have a red door that can be opened by activating a switch. So what we do, we go to the switch, and then we can perform the action that we need. So here is we perform the action, the interact action, and then we can finish our plan by going outside the room and grabbing the box. And simply with those simple ideas, like the navigation system and the action at every node, we believe that we can cover already a lot of cases in the game. So let's have a look of what it looks like to create our first plan in the editor with the tool. Here we have a similar level, but we have to collect the blue cube first, and then we will go on the top of the hill so we can jump to grab the box. So that's what it looks like in the editor. First of all, when we create our plan, we need to give it a meaningful name. Here it's our first plan. And once done, it will create a data asset in the content browser below. And that's where all the information about the test definition, the position of the nodes, the location, the action you want to perform, it's stored inside this asset. It's not stored inside the level itself. And from that, you can start building your plan like I said earlier. It's really easy to just place the node at the specific location that you want. And once it's done, you will be able to select the correct node where you want to perform the action. So we will select the input action, let's say, at the green switch. So it will be, we'll interact here. And we'll do the same thing for the jump. And once it's done, we simply save the plan, and we can play it directly and play in the editor with the play in editor mode to make sure that everything worked as it ended. So, and it's very easy to adjust the plan on the fly if there's some modification that we need to do. And there you have it, your first plan with Polaris. There will be situations in the game, of course, that are more complex than that. Sometimes you will have specific behaviors where you want to do a specific thing multiple times. Like here, I have some cube, so I would love to collect them all. And I don't want to put a node on each object that I want to perform an action on it. There's a smarter way to do it. Actually, in Polaris, there's the rule system, and it's a way to encode those behaviors directly. So it works on what the agent sees, and then you can associate an action or a sequence of action that you want to do to a specific object, here, the blue cube. So and once you got this rule, you can attach it to your existing plan or activate it at a specific node so it stops what it's doing and put the rule in priority. So this is a quick example to see how it works like in the editor. So we have exactly the same plan as before. And now I'm just attaching a rule that's called collect all blue cube. And I can simply run the plan as before. And as soon the agents see the cubes, it will collect them, then it will reset its current path. So a small recap. So far, the nodes are are located in the world. You can attach them to specific objects. You can perform specific action at those nodes. And you can create those rules for the specific game mechanic you have in your game. Of course, there's a lot of features, but I will go a bit more quickly about them because to be a bit faster for the presentation, but we can go a bit more in detail after talk. So one key idea that we have also is about for the navigation. Let's say that you have a nav mesh in your game that your NPC use to move around. With Polaris, it's very easy to use it as well. This way, if there's a new asset that's being brought into the world, the agent will be able to use the nav mesh instead of the waypoint to get to the target. And there's also the feature of teleport, where you can teleport to the node instead of running between them. So if you want to test different part of the area in your level very quickly, it's a great way to save time. There will be also a situation where you want to do a specific combo of action at a node, and you don't have to put multiple nodes for every action that you want to do. So let's say you have a chord. Let's say we have a chord of action, of input action. There's a way to do it very easily by using the blueprints or C++, the thing that you prefer. So it's like, let's say we want to code a double jump. So you just use a blueprint, code the sequence in Blueprint, and instead of using the action as we saw before, we just call the custom action at the right time. And with that same logic, there's a lot of flexibility to code how you want to validate your test. There's a feature to test the game state before an action and just after. You can specify at which node you want to do those tests or at the end of the plan. Like it's depending of your needs and what, and yeah, it depends of your needs. I went a bit quickly when we create our first plan about the dependencies. As you remember, all the test definitions are stored in a data asset. There's no relation between the game, the level, and the test. That means that you can create as many tests as you need. You can go as wild as you want, and you will never break the build. And unlike, let's say that there's the functional test framework in Unreal that does very similar thing that Polaris does, but you have to create the FTEST actor and place it in the world. So you have to maintain those actors, and it takes, and they are saved directly in the level. So let's have a look to the usual use case where Polaris is very useful. The first one is the feature test. It's when you want to test specific game mechanic or simply test the input of your game. You can test sprint, kicking, all the different actions. You can define specifically the test in gym or in your main level to make sure that your game mechanic are still working from one build to another. Another thing is, it's like the test we did before. You can validate the level's integrity, make sure that the player is able to reach the end. So you can do it by checkpoint, so in a way to cover the whole game. Or you can also do like a whole playthrough if you're motivated enough. And finally, there's also performance tests you can do with it. It's really easy to simply attach your favorite profiler on top of it. And what's nice about it is since the actions are scripted, the agent will always do the same sequence of action. So that means you can track the performance over time, and you can identify quickly when you have a drop in performance, and you can locate it. You can locate the place in the area in the world where it happens. And at the end of the day, Polaris is a plugin in Unreal 5, and under the hood, it uses a functional test framework. That means that you have access to the session frontend. You can schedule your tests automatically on the build. It means it will run on the quick build, of course. And as you saw before, you can use it in the play and editor to make sure everything works fine. And finally, at the moment, the plugin works on PC, PS5, and Xbox. And now Vincent will take the lead, and he will tell you more in detail about where Polaris fits in the life cycle of video game production.
Cool, thank you very much, François. So we've seen how now we have a tool that introduces a very simple abstraction, but that has very powerful feature that lets you define tests and success conditions without the need to code. And for those who absolutely want to code, there are ways to extend it, as we've also seen. So how does that change the development loop as it goes on every day? Well, let's look at actually the loop from the viewpoint of QA. Everything starts, of course, when there's a change made to the game. That's going to trigger build processes, which are then going to be taken by QA experts. And let's split the task of enacting the actual test and reporting on it. If you have automated tests going on, Polaris or not, then you have a similar lane going on. The orange lane is everything that's happening on compute, and everything that's connected and through compute is automatable as a sequence. So we can normally assume that everything that passes through the orange path is going to happen faster. If you have automated tests, not all of them are always going to be possible to report on automatically. You might have to assess the result in some cases. If your automated tests are robust enough, then the work you are creating by needing to report on them is not significant compared to the work you've saved yourself by running the tests automatically. So traditionally, without a visual tool like the one we introduced, there's a lot of friction when trying to put workload in the automated tests box because it's heavily development intensive. And since that development, if it happens in the scope of a single project, happens at the same time as the development of the game, you're missing a lot of opportunities to save money since you're not able to detect all the earliest bugs, the ones that are the most valuable to find. So when you have Polaris, from the get-go, you're able to put a lot of tests right in the automation lane, so you're catching all these early bugs without the need to develop a framework. And it also changes the mindset since you don't need to code. It's fast, and everyone is able to use it. So you have QA experts that instead of systematically running all the tests and their checklists, they're able to look at something and say, hey, can I automate that and put that myself in the automated test pipeline? So you have really this new dynamic where the experts at testing games are able to themselves decide what should be automated and what should not, which is really where the value lies here. So when you have Polaris, you're able to jump on in automated testing because of how quick it is to integrate it. We've brought that down to about 2 weeks to get on board with a new project. It's much cheaper to automate tests because you don't need to do a lot of dev from the get-go, either when creating or maintaining the tests. And yeah, so that gives you a loop of a QA along the process of development that is way more effective. Of course, saying that the development cost is very low is only true if, as a central team developing this tool, we're able to not grow our development workload with the number of projects that we support. So I want to tell you how we set up ourselves as a team building Polaris in order to scale with the number of projects that come in. So of course we're here, we're building this tool, it's still early, we have lots of exciting ideas, so we keep working a lot on it. And there's games in the studio that are happening also in parallel. And as soon as there's a persistent code base in the game, we're ready to integrate. There's no lower limit to the time where we can get in. So the first effort is going to be a joint effort with the production where we make all the decisions. Should the plugin be this or that type? Should the assets be saved at this or that location? Where should the build trigger the execution of the tests? We estimate this integration period to be an optimistic 1 week and a realistic 2 weeks, maybe. After that, as the Polaris team ourselves, we kickstart the test suites, since maybe we're integrating with a team that does not yet have experts using the tool. So that means we look at all the features, we look at what are the routines when testing the game, and we make all these very obvious preliminary tests that are just going to validate the game automatically really fast. And after that, we onboard whoever is going to be responsible for being the shepherd of all these small tests running in the build until we keep a support role in the background with the production. So the goal is really here to empower the QA with these tools so that they themselves are able to figure out where it fits and so that they're able to build the tests and operate them as the production goes. Of course, that can stop when the game is shipped, but if we have a game that is just always going on, we might as well keep going with them. So in that way, we're able to keep adding new projects to our support list. So in conclusion, let's just look at the recap of why we think this approach is a win for us when it comes to automating game tests at scale. First, this approach is highly reusable. Whatever features were requested, we evaluate or we find a way to make it such that it's always game agnostic. So everything we develop is always as game agnostic as possible and will be present and distributed in all future updates and all the future games that we support. We have a centralized development, which always happens in the same team, and the integration is highly streamlined such that we can get operational as fast as possible with productions. It's very easy to operate autonomously the tool once it's set up properly by us in the projects that we support. And the high-level abstraction that we presented with the nodes that define a bunch of conditions to succeed the test, to lend itself to a visual editing experience, as you've seen in the previous video. And as a note, also, there is a minimal impact to the code base because the Polaris suite has a very low overhead and is always guaranteed to be strippable by design. Before opening up for questions, I want to give you a glimpse of what other cool features we're planning to bring to this automated game testing suite. First of all, our most highly requested feature is to be able to record plans. So skipping the plan editing experience altogether, you can jump into the game and the nodes place themselves as you play along, as you trigger objects or interact with the scene. The actions are also recorded automatically. So this is coming. Also, multiplayer is going to be a very important part of the suite. It's not yet there. We're working on it. We're very excited to expand the scope of tests that we can support. And we're also planning in the long term to overcome the challenging things that happen. So there are some blind spots to the approach. Like, for instance, if there's very high randomness in the scene, we might need to have a smarter approach to have smarter agents to do that. With the Polaris suites, we can make setups to collect a lot of data and envision having reinforcement learning agents doing all the smarter work in the game.
All right.
Thank you.
Thank you so much.